Hey everybody. In this video lecture, we're going to talk about something called electric potential difference, which is better known as voltage. So let's take a look at this picture that I have drawn here. I've drawn some sort of material down there. This is going to be some sort of conductor. It's made out of charged particles, as is all matter. And I'm showing that there are excess electrons in this. So there are actually more electrons than there are protons. And let's compare it to these different locations. So the first location on the top left, you can see that there are actually more protons than electrons. And then I start to slowly work my way down to the right to where I actually get excess electrons. Now typically this type of figure is a little bit confusing to look at. And so we're going to simplify it down, as would many people. And every time I have one proton and one electron side by side, I'm going to remove them. This allows me to see what we would call the net charge. So now I know that the big sphere down at the bottom has a net negative charge of 5 units, the 5 electrons I'm showing. And then on the top left, I have a net positive charge of 2. If I start to compare locations, because remember a voltage is a comparison between two locations, I can say that there is a voltage or an electric potential difference between the big sphere and the small sphere. The electrons in the big sphere down below would like to be able to get over to this other location because they're attracted to it, because there are a lot of positive charges over there. And in fact, it's doubly so because they're repelled by the charge that's around them with the other negative charges. If we look at this next circle over up on the top here, we can see that we would still have a voltage, but it's not quite as much. It's not as large of a voltage because there's not as much of a desire for the electron to get over there, because there's not as much of an attractive pull from those excess protons on that side. I can still have a voltage going to something that's neutral, because this time it's just solely the repulsion of my bottom sphere, my bottom conductor down here, that is repelling electrons. I'm going to skip this fourth one and go straight to the fifth one, because I want to show you that even though I have 5 excess charges drawn in both locations, because the circle is smaller on the top right, it actually has more incentive for an electron to not want to be there, because I am asking my electrons, my excess electrons, to be more confined, and they have to be closer to each other in that particular case. So an electron would actually still want to move down to that bigger conductor down below, just because there's more room. That leaves me with this last one, which is kind of interesting because it's a smaller circle, but it has less charge. This alone, I can't really speculate on the voltage of this particular situation. But this kind of proves a point for me for why we are interested in voltage. I look at this diagram and it's difficult for me to make a judgment about where would an electron rather be. However, I can hook up something called a voltmeter, and I could just test these two different locations, and I would read a voltage if there was a desire for electrons to be on one side versus the other. Another extension to this concept, let's take the bottom conductor and smush it into a tighter space. I've left the charge alone, but now I've confined them into a smaller space. This increases the desire for the electron to get out of this location. And so whereas this was ambiguous before, now I can confidently say that the electron would like to move from the bottom location up to the top. Taking another look at this position that we had before, I haven't changed anything on the top right, and in this situation we would say that these two locations have the same electric potential, so there is no difference in their electric potential. That's by definition a zero voltage. This is going to be pretty happy to just stay as it is. No voltage, no push for electrons to move from one place to the other.
So just before we take the lid off of this thing, I just wanted to show you some close-up video here to show you how cool this thing really is. I don't know if it's really coming out clear on the camera, but it is just really something. And it sounds really cool too. So anyway, let's take the lid off of this thing and see what's going on inside. Okay, so I safely unplugged the 10,000 volt killing machine, and I know I probably don't have to say this, but this is 10,000 volts and it will kill you, so don't be stupid. And no, I'm not going to argue with you on whether or not 20 milliamps at 10,000 volts can kill you or not. I just always treat it as if it would kill me. So make sure it's always unplugged and you've got the right plug unplugged, right?